Have you ever just sat there and wondered, what would happen if the Earth just stopped spinning? Or, hey, what if you tried to hit a baseball pitched at nearly the speed of light? Well, today, we're going to dive headfirst into the brilliant and frankly bizarre world of Randa Munro's book, What If?, where the most out-there questions get some seriously scientific answers.
And this quote right here, this is the heart of the whole thing. It's all about celebrating that pure, unadulterated curiosity. It shows us that sometimes the weirdest, silliest-sounding questions can actually lead you down a rabbit hole to some of the most fascinating science out there.
Now, the mind behind all this is Randall Munro. You probably know him from his legendary stick figure webcomic, XKCD. But, and this is the cool part, before he was drawing comics, he was a roboticist for NASA. So that background gives him this perfect mix of real scientific know-how and this wonderfully strange imagination to even think of tackling these questions.
Okay, let's just jump right in with our first scenario. And we're not starting small here. We are talking about a full-on planetary-scale catastrophe.
So here's the question, which came from a reader named Andrew Brown. Picture this. The ground beneath your feet just slams on the brakes. Hard stop. But all the air, the entire atmosphere, keeps going at its original speed. What happens then?
Well, the immediate result is a windstorm that makes any hurricane look like a gentle breeze. See, at the equator, the atmosphere would still be whipping around at over 1,000 miles per hour. That is faster than the speed of sound. You've basically just created a supersonic blender that's about to scour the entire surface of the Earth.
And just look at the sheer scale of this thing. This isn't some local disaster. That zone of supersonic winds covers the area where 85% of all human beings live. Every single building, every skyscraper, every house, just torn from the ground and shattered into dust in like minutes.
So, is anybody going to make it? Well, maybe, if you just happen to be chilling deep underground. Munro points out that Helsinki, Finland, has this huge network of underground tunnels, shopping malls, even a hockey rink. So, for the handful of people who survive, they get the last laugh, I guess. But for everyone on the surface, yeah, you're pretty much out of luck.
But here's the thing. After all that unimaginable chaos and destruction, there's this surprisingly beautiful little twist. Our moon, our constant companion up there in the sky, would actually start to fix things. Its gravity would start gently tugging on our now still planet. And slowly, over thousands and thousands of years, it would get the Earth spinning again.
All right, so for our next question, we're going to zoom in from global destruction to something that feels a little more personal. And by personal, I mean, something that just levels an entire city.
It seems simple enough, right? A sports question, just with a little physics twist. You're up to bat, here comes the pitch. And it is coming fast. No, I mean really, really fast. Let's try to wrap our heads around this. We are talking about a baseball moving at over 600 million miles an hour. At that speed, the air molecules in front of it, they literally don't have time to get out of the way. It's like a brick wall for them. So here's where it gets truly wild. The ball doesn't just push the air. It slams into the atoms of oxygen and nitrogen so hard that their nuclei actually fuse. That is nuclear fusion, happening right there on the pitcher's mound. And it unleashes this massive blast of gamma rays and other particles. And all of this happens in, well, basically no time at all. We're talking nanoseconds. The air in the stadium just erupts into a searing hot bubble of plasma. A shell of X-rays, moving at almost the speed of light, actually reaches the batter before the ball does. You wouldn't even see the pitch. You'd just be gone. And the final result? Well, it's pretty much what you'd expect from a nuclear fusion event at a ballpark. It's an explosion on the scale of a nuke. Everything for a mile around is just flattened. A firestorm tears through the city. And where home plate used to be, yeah, that's just a crater now.
But of course, after all that mind-bending physics and utter devastation, Munro hits us with the perfect deadpan punchline. According to the official rules of Major League Baseball, the batter was, technically, hit by the pitch. So, assuming first base still exists, he gets to take his base.
Okay, for our last scenario, let's just switch gears completely. We've done global winds, we've done nuclear baseballs. How about something that sounds incredibly dangerous, but, well, the answer is pretty different?
So this question comes from a guy named Jonathan, and let's be honest, it sounds like a terrible, terrible idea, right? Swimming around on top of highly radioactive nuclear fuel.
So here's the basic setup. When nuclear fuel rods are used up,
they're still super hot and incredibly radioactive. So they get stored for years at the bottom of these really deep pools of water. The water does two things. One, it cools the fuel down, and two, this is the important part, it acts as a radiation shield.
And here's the absolute shocker. It turns out water is an amazing radiation shield. Just a few feet of it is enough to stop basically all the dangerous radiation coming from the fuel way down at the bottom. You could swim around on the surface totally fine. In fact, the water would shield you so well from normal, everyday background radiation that you'd actually get a lower dose than you would just walking down the street. Just, whatever you do, don't dive down to the bottom. That would be bad.
Of course, there's the physics answer, and then there's the real-world answer. When Monroe actually asked someone who works at a research reactor, he got a much more practical reply. The radiation wouldn't get you, the armed guards would.
So, okay, after all of these wild thought experiments, total destruction, surprising safety, you gotta wonder, what's the point of all this? Why bother thinking about these absurd hypotheticals?
And I think the real takeaway is this. It's not actually about finding the right answer. It's about the journey you take to get there. It's about using science and logic to puzzle your way through a ridiculous problem. And in the process, you end up learning about atmospheric physics and nuclear fusion and even the official rules of baseball. That process of discovery, that's the real reward.
And that's really what makes this whole idea so powerful. It just sparks your own curiosity. It makes you start asking your own what-if questions. So, what absurd scenario would you want a serious scientific answer for? The possibilities, after all, are pretty much as endless as the universe itself.